Now, if you're trying to solve genetics problems using blood, you simply have to memorize this, because it's really hard to just answer questions dealing with blood type unless you understand the genetics behind it. And it's not simple Mendelian genetics. So basically, there are 4 different phenotypes. So you could be type A, B, AB, or O. But there are 6 different genotypes. And so if you're type A, like I am, you could be A because you have both of these alleles for A, or you're homozygous, or you could be heterozygous. You could have one of the alleles for the A protein, but the other one doesn't make a protein at all. That's how you get the type O, if you have 2 alleles and neither of those express the protein. If you're type B, again, you could be homozygous for both of those, or you could be heterozygous. But if you're type AB blood, then you're going to have one of each. And so we call this expression, well, multiple alleles, because we have more than one allele. We have 3 in this case. And also it's codominant, because if you're type A and B, you don't have like one being dominant. You're actually expressing both of those. And so if you're ever trying to solve problems, they're never going to give you this genotype. So you really have to memorize this. I, or the AP folks, are just simply going to ask you a question like this. Is it conceivable that we could have a father who is type A and a mother who is type O, and they could have offspring that are going to be type B, we'll say, for example? Well, to solve this, let's look at a couple of Punnett squares. If you're type A, we just write that across the top. So you could be this, you could be homozygous for that A. We know that the O is going to look like this, and so we could figure out that all of the offspring, if the parent is homozygous, is going to be type A. But if we kind of delete that a second, let's say that they are heterozygous for it. Let's say that person who's type A is going to be like that, and then O looks like this. Well, we could get this possibility. This person would be type A blood, but we could also get this possibility with this one being type O blood. Or you could solve questions like this. Let's say that we have one parent who's A and one parent who's B. What possibilities could we have for their offspring? Well, let's look. If one is A and one is B, if they're both homozygous, then we would have AB blood for all of their offspring. But let's set it up another way. Let's set it up like this. Let's say that one is heterozygous for it, like that. And then the other one is heterozygous for that trait. So let's say dad is B, but he's heterozygous for that trait. Well, if we look at this possibility in fertilization, this person would be type AB blood. This person right here is going to get the A from up here and the I from over here. So this would be type A blood. This one right here would be B blood. And then this one right here, since you're getting both of these little I's, is going to be type O. So if you have an A and a B, you could conceivably get AB, B, A, or O type blood coming from that. And so make sure you understand the different genotypes that we have, especially up here for those who are type A and type B.